Hello friends, welcome to Rajavali Education channel. In this video, we are going to see experiment and derivation part of motional electromotive force. First, we see the experiment part. Let us consider this uniform magnetic field. These field lines are represented by crosses as shown in the page. Its field lines are perpendicular to the plane of the paper and pointing inwards. A rectangular metallic frame PQRS is placed in this magnetic field. The arm PQ is movable so that it can slide towards right or left with its plane perpendicular to the field. Here you can see this. If the arm PQ slides to our right side, the number of field lines passing through the frame PQRS increases and a current is induced. As suggested by Lenz law, the induced current opposes this flux increase and it tries to reduce it by producing another magnetic field pointing outwards, that is, opposite to the existing magnetic field. The magnetic lines of this induced field are represented by red colored circles. From the direction of magnetic field thus produced, the direction of the induced current is found to be anticlockwise by using right and thumb rule. So the induced current direction is anticlockwise direction. If the arm PQ moves left side, the magnetic flux decreases. To counter the reduced magnetic flux, new magnetic field lines are produced. The new magnetic field lines are represented by red color crosses. These magnetic field lines are inward direction, that is, the direction of the existing magnetic field. Therefore, the flux decrease is opposed by the flow of induced current. So from the right hand thumb rule, we can find out the direction of the induced current, that is, it flows in clockwise direction. When the area enclosed by the loop decreases, the induced current direction is clockwise. At the same time, when the area enclosed by the loop increases, the induced current is an anti-clockwise direction. We have seen that experiment part. Now we see the derivation part. PQ is equal to SR is equal to L and RQ is equal to X. Next we find out the magnetic flux enclosed by the loop PQRS. That is, magnetic flux is equal to B into L into X. The rate of change of magnetic flux will induce an EMF. So EMF is equal to minus d pi b by dt. Substituting this pi b value, that is magnetic flux value, we get this one. So rearranging the equation, we get minus b into L into dx by dt. Since x is changing with the time, we get dx by dt is equal to minus v. So minus into minus, we get BLV. BLV is known as motional EMF. It is also possible to explain the motional EMF expression, that is BLV, by invoking the Lorentz force acting on the free charge carriers of conductor PQ. Consider any arbitrary charge Q in the conductor PQ. When the rod moves with the speed v, the charge will also be moving with the speed v in the magnetic field V. The Lorentz force on this charge is QVB in magnitude and its direction is towards Q. All charges experiences the same force in magnitude and direction irrespective of their position in the rod PQ. So the work done in moving the charge from P to Q is force into distance traveled by the charge. So force is QVV and distance moved by the charge is L. So work done is equal to BVQ into L. Since the EMF is the work done per unit charge, we can say EMF is equal to work done by Q. So BLVQ divided by Q. By cancelling Q, we get EMF is equal to BLV. I hope you understand the concept of motional electromotive force experiment and the derivation part. Thank you for watching.